But wait, there's more. There's a couple more data types we need to cover. These are different from the basic primitive data types we just covered, but equally as important because you're guaranteed to use them in almost every trigger. These new data types fall under a category called collections. A collection is just a group of records, all of which have the same data type. Whereas a primitive variable we covered earlier just represents one instance of a data type, a collection has multiple instances of records, all of which share the same data type. This should help make it a little bit more obvious. Let's say we have a collection and we're storing it in a variable we're calling user IDs. Notice this is plural. IDs, not ID. This particular collection would be a collection of strings. So normally, a string variable would carry one value, not our collection. Our user IDs collection would store many strings. The same could be said about a collection of any other primitive data type, for example, dates. We can create a collection called end of quarter dates that stores one date value for each quarter's end date. Starting to get the picture? Here's a few reasons why we use collections. First of all, collections help keep our code organized. Think of them to be sort of like list views. Yes, you might have many different opportunity records, but it's helpful to have a list view that organizes your opportunities into different groups. For example, you might have a list view for opportunities with a close date in January. Similarly, you might have a collection of opportunities closing in January. Another reason why we have collections is they let us run our logic in bulk. List views represent another perfect example of this. Yes, your reps can click on each individual opportunity, edit it, then save, but it's more efficient if they edit all their opportunities at once using the mass edit feature of a list view. The same applies in code. Why do things manually one at a time when you can do them all in one fell swoop? The better you get at coding, the more you'll be using collections. It's what a lazy person would do. And remember, laziness is good when coding. There are two types of collections we'll be covering. The first is a list, and it's the one you'll be using the most often. Lists are just an ordered collection of records. The key word here is ordered, meaning every record in your list has a position, whether it's the first, second, or last record in your list. Here's how to create a list. Before you create a list, you have to decide what data type each record in your list will have. In this example, it's string. So when we create a list of strings, we type string inside the caret signs. We'll give our list variable the name names, then we'll instantiate a new list of strings after the equal sign. Notice the syntax there. It's always exactly like that, only the data type inside will change. This now creates the structure, the foundation of a list. Our list has been created, it just doesn't have any values yet. In the next two lines, we use the special add method in our list to add two strings to it. When using a list, always remember to create the list before adding values to it. This just means using the new list syntax we used in the first line in the example above. I still forget to do this sometimes, and you probably will too. Start good habits early. Another thing to know about lists is that lists start counting at 0, meaning the first value stored in a list is actually in position 0, and the second value stored in a list is in position number 1. I believe this is totally ridiculous, and whoever made this decision should get a swift kick in the rear. But it is what it is. Final note, lists don't automatically dedupe values for you. So if I added two names, each named David, to the list above, then the list would have two Davids in it. Get is a secret method of lists that gives you the value in any specified position. Remember, counting starts at 0. So if I used get 0 in our list above, it'd give me the name David. If I used get 1, it'd give me Jody. There's also a sort method, which rearranges the positioning of records in a list. And there's also a size method, which gives you the number of records currently in our list. Using the size method in our list above would give us the number 2. True story. By now, you've already used lists, because our good friend trigger.new is actually a list. It's a list of S objects. And in this trigger, the specific S object would be opportunity. Oftentimes, your list will have an S object data type, just like trigger.new here. The second and last type of collection we'll cover is the set. A set is just like a list, but it's unordered, meaning each record inside of it has no specific position. Creating a set is just like creating a list. First, we choose the data type. Then we give our set a variable name. And finally, we create our empty set using the new syntax here. Don't forget the parentheses at the end. Similarly, we add values to our set using the add method. Now at this point, you may be wondering, why bother using a set when a list does essentially the same thing and preserves the order of records inside of it? Good question. Clearly, you've been taught well. Having no responsibility to preserve the positions of records has its advantages. For one, it's a lot more efficient. One less thing for the computer to keep track of. And with this added efficiency, you get access to awesome powers, like built-in deduping power. See the example above where we add the number 3 twice to our set of prime numbers? No problem. Our set combines that 3 with the original number 3. So even after those lines of code, our set only has 2 values. Very powerful. However, note that sets don't automatically dedupe S object records for us. That's a little bit more of an art than a science. So sets leave that deduping up to you. Another bonus of the extra efficiency sets have is they have access to a secret method called contains. Contains automatically searches your set for a specific value and tells you if it's there or not. Lists do not do this out of the box for you, but sets do. Otherwise, sets and lists share a lot of the same methods such as add, size, and isEmpty. Note, however, that sets don't have a get or sort method. Since positions don't exist in sets, it doesn't make sense to have those methods.